Okay, so the last thing we need to do is figure out how to name covalent compounds. So the ability to understand and to know how to create formulas for covalent compounds will require a little more detailed knowledge about covalent bonding and sharing of electron pairs before you can accomplish that aspect of covalent bonds, and that's really more of an AP topic. This won't happen for a while yet, or probably won't in the regular class here. So we won't worry for now about how we come up with covalent formulas. We'll just know that we have them, but we still can figure out the basic naming of these. So for our purposes, covalent compounds, just like ionic compounds, will consist of two components. But in covalent compounds, both will be nonmetals. You need to know that. Now, because these are not ionic compounds, we won't consider so much the concept of charges, but rather how many spaces does a given element have for sharing electrons in their outer shell. Okay, so we aren't going to consider +3 and -2 and how that fits together. We're going to look at how many electrons are available to interact in the outer shell. So another way to look at that would be how many unpaired electrons does the atom have to share with another element. And here's what I mean by this. So consider the element nitrogen. It has 5 valence electrons, and we've said before that we can write a little shorthand of this structure by putting dots around the atomic symbol, 1, 2, 3, 4, 5, and that shows us that we have 3 electrons available for interaction with other electrons. Okay, so if 3 hydrogen atoms came along and were to interact with a nitrogen atom, nitrogen can form covalent bonds with each of these 3 hydrogens, and we're showing this here. Here's 1 electron that could be shared, here's another electron that could be shared, and here's another electron that could be shared, so that if that happens, we'll get 3 covalent bonds for nitrogen, one with each of the free electrons that nitrogen has. Notice these are covalent bonds. No transfer of electrons has occurred. Again, they're shared, so no ions have been formed, so there are no charges to be considered. So now our goal is a little bit different. It's given the formula for a covalent compound, what is the name of the compound? Again, we're mostly going to consider compounds that have 2 components composed of 2 elements, both nonmetals. And this means no polyatomic ions. So in the formula, the element which is further left in the periodic table is usually the element that's first in the formula, although compounds with hydrogen in them will often be an exception to this, like the ammonia is, right? This is given the symbol or the chemical formula NH3, whereas hydrogen is first in the periodic table. Okay, so in the first step, just like with ionic compounds, the first component, the first element in the formula is simply the name of the element. Okay, in contrast to ionic compounds, we don't have to worry about Roman numerals or transition elements for transition elements or polyatomic ions. So we're going to start by listing the names of the first elements, but again, we're going to leave a little bit of space between the formula and the beginning of the name, and you'll see why in just a second. Okay, and then come back here and click to make sure that your answers are correct. But we're going to go to a list. Okay, so move over a little, separate, and we put down carbon. Again, we put down carbon. Carbon, sulfur, phosphorus, nitrogen, and boron. Okay, so these are the first names, and this is our first step. Okay, just the names of the elements. So go back to the presentation, and you can see here, that this is exactly what I've done in the image here. Okay, so I've just written that first name down. Okay. For the second step, the second component, just as with ionic compounds, the ending of the name of that element is dropped and the suffix IDE is added. Again, go ahead and list the names of the second components, but again, leave a little bit of space at the beginning of the name to add something, and then come back and click to check your answers. Okay, so for oxygen, it's going to be oxide. Okay, again for oxygen, it's going to be oxide. For sulfur, it's going to be oxide. For fluorine, it's going to be fluoride. For oxygen, it'll be oxide. For oxygen, it'll be oxide. And then for fluorine, again, it will be fluoride. Okay, so go ahead and make sure these are on your worksheet, and go back to the presentation, and you'll be able to check your answers there. So we'll just close that, and let me click this here and show you that again you can click or see your answers. Okay. Okay, so the main difference between naming ionic compounds and covalent compounds is that for the names of the components of covalent compounds, we use prefixes to indicate the number of the subscript. That is, the number of atoms of each component of the formula, and this is a list of those prefixes. Okay, so for 1 we have mono, for 2 di, and etc. And the only additional rule for this is that we always use prefixes to indicate the number of atoms of the second component of the compound, but we don't use the prefix mono in the first component name. So for example, I would never say monocarbon monoxide, okay? I would always just say carbon monoxide. But if I have more than one atom in the first name, I would use a number prefix. So go ahead and finish that out, and then come back and check your answers. Okay, so for just one carbon, again, we don't use mono, but we will use dioxide. For 2, carbon dioxide, you're familiar with that compound. For carbon with 1 oxygen, we'll use the prefix mono, except that would give us 2 O's in a row, so we would say it wouldn't be monoxide. We would just eliminate one of the O's and say monoxide. Then sulfur is going to be dioxide. Sulfur with the 6 fluorines is going to be hexafluoride. And now I've got a first name with more than one, so we're going to go diphosphorus pentoxide. And oftentimes when we have 2 vowels in a row in this, we'll eliminate one of them and just say pentaoxide instead of pentaoxide, although it wouldn't be wrong to say pentaoxide either. And then we're going to say trinitrogen pentoxide. And then finally boron trifluoride. Okay, so pretty straightforward. Go ahead and close this. Go back to the presentation here and click the check. So make sure your answers are consistent with these. And that's the end of this video and the end of this topic. Okay, so we've had 3 fairly lengthy discussions about compounds, and we've got a lot of information covered, and now you get to have a test. So go ahead and submit the worksheet and find out more about the test. So we'll close this.